Hi friends, welcome back to my physics channel once again. So we are in the fifth topic or fifth chapter or fifth unit in the second year new syllabus physics intermediate, board of intermediate. Now let us start the seventh video regarding short answer questions and these are 4 marks questions. Short answer and these are 4 mark questions. Let us see, we are having only few questions 4 marks in this chapter, and this chapter itself is a very small and video 7th video. Let us start with the first one, please. చూడండి ఒకసారి, మెన్షన్ ద ప్రాపర్టీస్ ఆఫ్ మ్యాగ్నెటిక్ ఫీల్డ్ లైన్స్. 4 మార్క్స్ కాబట్టి మినిమం కనీసం 4 మార్క్స్ తగ్గట్టు మనం దానికి డీటెయిల్స్ ఇవ్వాలి. మెన్షన్ ద ప్రాపర్టీస్ ఆఫ్ మ్యాగ్నెటిక్ ఫీల్డ్ లైన్స్. దిస్ ఇస్ ద ఫస్ట్ క్వశ్చన్. మ్యాగ్నెటిక్ ఫీల్డ్ లైన్స్. So what do you want to do? Write the properties of magnetic field lines. So you can start off with the first one. These are very clear. These are very clear and distinct lines. Okay, you can, I will draw the figure also for you with the different things. Magnetic field lines draw chestunnaను చూడండి. For a bar magnet, if you take north and south, starts with north, magnetic lines ends with south. Okay, you can see. So these lines, if you observe carefully, these are very clear and distinct lines. Okay, these are very clear and distinct lines, magnetic field lines. చూస్తున్నారు కదా ఫిగర్లోని, రైట్. దట్ ఈస్ ద ఫస్ట్ వన్. సెకండ్ వన్, if you draw tangent at any point, you will get the direction of magnetic field. Second one, if you draw tangent at any point on the line, that is on the field line, we will get the magnetic field direction. We will get the direction. That is the second point. Third point, no two lines will meet each other. No two lines will meet each other. చూడండి, no two lines are meeting. Suppose if they are meeting, for example, చూడండి, if they are meeting like this, then what happens? There will be two directions. So this is one magnetic field direction, and the tangent, if you draw, this is another direction. This is B1 and B2. So two directions are impossible. So that is why no two lines will meet each other. Okay? And last one, you can take fourth point. They always start from north and ends to south pole. Because we know in magnetism, any magnet, if you take, no monopoles are existing. North pole, south pole vere unda kabatti they always start from north and ends with south. So these are some magnetic field lines properties and 4 marks. Please note down. అయిపోయిందా? రైట్ అండి. shall I go to the next one? నోట్ చేస్తున్నారు 1 2 3. రైట్. సెకండ్ క్వశ్చన్. సో 4 మార్క్స్ కాబట్టి మినిమం 4 రాయండి, ఎక్స్ట్రా ఒకటి రాసినా పర్వాలేదు. రైట్. నెక్స్ట్ వన్, స్టేట్ Gauss laws in magnetism. Show that how this law prove that non-existence of magnetic monopoles. State Gauss laws in magnetism. Second question. Second one, Gauss laws in magnetism. See, we all know Gauss laws are very familiar in electrostatics as well as magnetism. So what Gauss law says, suppose if any closed surface is there, okay, so he said that the integration of that closed surface, that is B dot dA that is elemental surface, is equal to 0. Why 0 here? Because in magnetism, monopoles do not exist. Monopoles do not exist. What does it mean? North pole separate ga, south pole separate ga undavu. Even if you cut the smallest piece of a magnet, that small piece still acts as a magnet as north and south pole gani. As like electrostatics, positive negative charges separate ga undavu. So because of that, the net magnetic moment is 0, and not only that, the net flux is equal to 0. Net flux is equal to 0. Okay, because north and south pole existing at the same point, separate undavu. So therefore, this is the mathematical formula: closed surface integration B dot dA, magnetic field induction dot dA is equal to 0. Okay na? So these are the things you have to explain. But idantha kuda meeru material ga rayali. Okay na? You have to write down one by one rayali. Since in magnets there are no, ఇక్కడ రాసుకోవాలి, క్లియర్గా పాయింట్ వైజ్ రాసుకోవాలి. In magnetism there are no north and south separate poles. In magnetism there are no north and south poles separately. They exist as pairs. In any magnet, in any smallest piece of magnet. Okay na? And not only that, the net flux is equal to 0. That means the net magnetic moment is 0. The net magnetic moment is equal to 0. So therefore integral B dot dA, that small surface closed surface, is equal to 0. Andike Gauss laws are not familiar in magnetism, but these are familiar in electrostatics. So these are the points, and because no monopoles exist in magnetism, there are no north and south poles separately. So they exist in pairs in any smallest piece of the magnet. Net flux is equal to 0.5, and therefore net magnetic moment is also equal to 0. Clear last one, is it? Net magnetic moment is also equal to 0. Net magnetic moment is 0. So that is the second one, and 4 marks. And going to third question, short answer questions, and please make a note, this is 7th video. Explain the properties of diamagnetic materials. Okay na? Explain the properties of diamagnetic. Next one andi. Third raskondi, properties andi, jagattaga raskoవాలి అవి. Properties of diamagnetic substances లేదా materials. So one by one raskondi. These are strongly repelled by the magnets. First point raskondi. These are strongly repelled by the magnets. Example. First one, properties are neat ga 1.4 marks question. Neat ga rayali. Properties of diamagnetic substance. These are strongly repelled by the magnets. Example: copper, antimony, bismuth, hydrogen gas, etc. These are some examples: copper, antimony, bismuth, hydrogen gas, etc. Okay, examples. Second one, the movement. You can see movement when placed in a non-uniform magnetic field. Okay na? So what happens? They tend to move from stronger parts to the weaker parts of the field. Adi kuda raskondi. You can take when these when these are, they move from stronger part of the field to weaker part of the field when placed in a non-uniform magnetic field. When placed in a non-uniform magnetic field. అదవుతుందా? సో దిస్ ఇస్ ద సెకండ్ ప్రాపర్టీ ఆఫ్ డయా. ద మూమెంట్ అంటే ఎలా మూవ్ అవుతాయి? దే మూవ్ ఫ్రమ్ స్ట్రాంగర్ పార్ట్ ఆఫ్ ద ఫీల్డ్ టు ద వీకర్ పార్ట్ ఆఫ్ ద ఫీల్డ్ వెన్ ప్లేస్ ఇన్ ఏ నాన్ యూనిఫామ్ మ్యాగ్నెటిక్ ఫీల్డ్. దట్ యూ కెన్ యాడ్ ద సెకండ్ పాయింట్ డయా. స్ట్రాంగర్ పార్ట్ నుంచి వీకర్కి. థర్డ్ పాయింట్ ఐల్ రైట్ దిస్ సైడ్. డయామాగ్నెటిక్ ప్రాపర్టీ థర్డ్ వన్. ప్లీజ్ రైట్ డౌన్ ద థర్డ్. రాసుకున్నారా? నోట్ చేస్తారా? థర్డ్ పాయింట్ రాసుకోండి ప్లీజ్. ఓకే, జీటా వాల్యూ ఇట్ ఈస్ స్మాల్ అండ్ నెగిటివ్. సో హియర్ ద థర్డ్ పాయింట్ జీటా, that is magnetic susceptibility is small and a negative value. That is the third point. Please, you can make it. తెలుసు కదా జీటా అంటే ఏంటనేది? జీటా ఇస్ నథింగ్ బట్ వాట్? I by h. I by h is equal to జీటా. తెలుసు కదా? I is proportional to h, depends upon h value. The ratio of I by h, zeta, susceptibility. It is very small, small and positive, please. Fourth point also you can add. Note cheskoni itipakku kuda cherpestan. Please make it fast. Fourth point. Rayandi. Fourth edentante dialoni very very important temperature anamata. Entidi? The magnetic properties are, so in this one, independent of temperature. These are independent of temperature. Even if you increase or decrease, that does not depend upon the temperature. This is the another important points and right. So the magnetic properties does not depend upon the temperature. Even if you increase or decrease the temperature conditions, it is independent, irrespective. So these are the four important points in the diamagnetic substance. They are strongly repelled. Copper, antimony, bismuth, hydrogen gas, they move. That means when these diamagnetic particles are placed in a non-uniform magnetic field, they move from stronger part to weaker part. Okay na? And the zeta value, I by h, intensity of magnetization to the magnetization field ratio is small and negative value. And the properties here in the magnetic properties are does not depend upon the temperature. That is the dia. ఓకేనా? చెప్పేస్తున్నానండి. సో ఇది కొంచెం థియరిటికల్ పాయింట్స్ కాబట్టి జాగ్రత్తగా రాసుకోవాలి మనం. నెక్స్ట్ క్వశ్చన్. సో దిస్ ఈస్ ద స్టోరీ అబౌట్ డయామాగ్నెటిక్ సబ్స్టెన్స్. రాసుకోండి కదా అది? రైట్ అండి. లెట్ us go to the next one. 4 marks. Explain the properties of paramagnetic substances. Fourth one. Fourth అడుగుతున్నాడండి. Explain the properties of paramagnetic materials. Please make a note. This is the 7th video we are doing for this magnetism matter chapter. This is 4 marks question, short answer. So he is asking the fourth question lo paramagnetism gurinchi adugutunandi. So paramagnetic man telusu kada, these are feebly attracted by the magnets. First one, these are feebly attracted, small attraction, feebly attracted by the magnets. For example, aluminium, manganese, oxygen gas, etc. Platinum also you can take. Platinum and magnesium also if you want you can take. These are paramagnetic. Okay na? But ఎక్కువగా వాడతాం aluminium, manganese, oxygen gas, etc. These are feebly attracted by the magnets. That is the first property. Please note down. Kasnara? Clear? Next one. ఇక్కడ దీనికి ఇందాక డయామాగ్నెటిక్ ఇది ఆపోజిట్ అనమాట. ఇందాక డయాలో ఏం చెప్పుకున్నాం మనం, దే మూవ్ ఫ్రమ్ స్ట్రాంగర్ టు వీకర్. హియర్ దీస్ మూవ్ ఫ్రమ్ వీకర్ టు స్ట్రాంగర్ అనమాట. ప్లీజ్ రాసుకోండి. ఓకే, రైట్ అండి. దీస్ మూవ్ ఆపోజిట్ అన్నమాట. దానికి డయాకి ఆపోజిట్. దీస్ మూవ్ ఫ్రమ్ వీకర్ ఫీల్డ్స్ to stronger fields, to stronger fields. The movement will be from weaker fields to stronger. Dial aithe stronger to weaker fields andi. That is the next point here. Please note down. Okay, right andi. Next one, third point, zeta, that is I by h, which equal to zeta. Susceptibility, magnetic susceptibility. Okay, that is magnetic susceptibility. Magnetic susceptibility zeta. In this value is positive and small and positive, please. Okay, na? It is small and positive. Value is small and positive. Whereas in dia it is small and negative. Okay, please write down very, very important properties and small and positive. Next one, regarding Curie's temperature, Curie's law. That is zeta value is inversely proportional to absolute temperature. That is I by h, that is called as Curie's law, scientist. Zeta value is inversely proportional to absolute. That means when you increase the temperature, depends upon temperature, this increases, this decrease అవుతుంది. If this increases, this decreases. Inversely proportional to absolute Kelvin temperature. Okay na? Right అండి. So these are another 4 points in the paramagnetic substances. Clear? 4 marks కాబట్టి 4 marks తగ్గట్టే మనం రాసుకోవాలి. Written? రాసుకోండి. 1, 2, 3 చెరిపేస్తాను. We'll go to the next one immediately. That is 5th one. కొంచెం theoretical part అండి. You have to bear with me. Next 5th question, that is 4 marks. We are entering. This is also another very much theoretical point అండి. How the existence of domains explain the behavior of ferromaterials, that is ferromagnetic materials. Okay na? So another theoretical question and is asking you about the existence of domains and explain the behavior of the ferromagnetic materials. So ఇది theoretical points కొంచెం జాగ్రత్తగా నోట్ చేసుకోండి, మీకు చెప్తాను. ఓకేనా? రాయండి. ఇన్ ferromagnetic materials రాసుకోండి. theoretical part, in ferromagnetic materials. So you have to explain. కొంచెం బోరింగ్లో అనిపించవచ్చు, బట్ యూ హ్యావ్ టు రైట్ డౌన్ కదండి, వదిలేలేం కదా, అన్ని మ్యాథమెటికల్గా ఉండవు కదా. ప్లీజ్ రైట్ డౌన్. ఇన్ ferromagnetic domains I'm explaining. In ferromagnetic materials, atoms are grouped into small regions. In ferromagnetic materials, atoms are grouped into small atoms are grouped into small regions called domains. ప్లీజ్ రాసుకోండి. ఇటుపక్క జరిపేస్తాను. ఓకే, theoretical points. In ferro, what we have is atoms are grouped into small regions and these are called as domains. Okay, where all magnetic materials are aligned in the same direction. So here what happens, all magnetic materials are aligned in the same direction aligned in the same direction. This is the first thing regarding domains. In ferromagnetic materials, atoms are grouped into small regions called domains. All magnetic materials are aligned in the same direction, please. All magnetic moments, and please, not materials. All magnetic moments. All magnetic moments. All magnetic moments, that is M to LM, are aligned in the same direction. Okay, adotandi. Next, the unmagnetized state. Unmagnetized state. Regarding unmagnetized state, raskondi. It's theoretical point. Tappadu, you have to write down. When an external field is applied, when an external field is applied, okay, when an external field is applied, domains pointing in the fields, domains, adotandi meeku. So next one, in unmagnetized state ఎలా ఉంటుందో పరిస్థితి చూద్దాం regarding the domains. When an external field is applied, domains, write down, domains pointing in the field's direction, domains pointing in the field's direction, theory కాబట్టి రాయాలండి, వదిలేయకూడదు. In the field's direction, grow larger, please write down, grow larger, or other domains rotate. Other domains, please write down, please. You have to bear for a few minutes because this is a boring one. Theory part ఇప్పుడు boring ఉంటుంది, అన్ని మ్యాథమెటికల్ ఉన్నాయి కదా. ఓకే, ఇన్ అన్మాగ్నెటైజ్డ్ స్టేట్ ఏమవుతుంది, డొమైన్స్, when an external field is applied, domains pointing in the field's direction grow larger, okay, and other domains rotate to align with the field. Other domains rotate to align, please write down, align with the field, field వైపు తిరుగుతాయి అన్నమాట, with the field, rotate to align with the field, resulting in a very strong please write down, resulting in a very strong magnetic effect. Are you following? See, theory part వచ్చినప్పుడు you have to bear it. ఓకేనా, మన మ్యాథమెటికల్గా వచ్చినప్పుడు ఎంత ఆనందిస్తామో, థియరీ పార్ట్ కొంచెం బోరింగ్ అనిపించినా you have to bear it. ఓకేనా, వెరీ స్ట్రాంగ్ ఓవరాల్ మ్యాగ్నెటిక్ ఎఫెక్ట్ అండి, అర్థమవుతుందా? సో దిస్ ఈజ్ ద స్టోరీ రిగార్డింగ్ ద ఫెర్రోమాగ్నెటిక్ సబ్స్టెన్స్ అనమాట. అదే కదా అడిగాడు మనకి ఫిఫ్త్ క్వశ్చన్, హౌ ద ఎగ్జిస్టెన్స్ ఆఫ్ డొమైన్ ఎక్స్ప్లెయిన్ ద బిహేవియర్ ఆఫ్ ఫెర్రోమాగ్నెటిక్ మెటీరియల్ అడిగాడు, ఫిఫ్త్ వన్. ఓకేనా, సో ఇన్ ఫెర్రోమాగ్నెటిక్ మెటీరియల్స్ ఆటమ్స్ ఆర్ గ్రూప్డ్ ఇంటూ స్మాల్ రీజన్స్, చిన్న రీజన్స్ గ్రూప్ అయిపోయి, కాల్డ్ డొమైన్స్. ఆల్ మ్యాగ్నెటిక్ మొమెంట్స్ ఆర్ అలైన్డ్ ఇన్ ద సేమ్ డైరెక్షన్. ఓకేనా, తర్వాత అన్మాగ్నెటైజ్డ్ స్టేట్లో వెన్ అన్ ఎక్స్టర్నల్ ఫీల్డ్ ఈజ్ అప్లైడ్, domains pointing in the field's direction grow larger, other domains rotate to align with the field, resulting in a very strong magnetic effect. So this is the story, 4 marks about domains andi. Clear? Now we are entering into the last question andi. Last one, adi ఆరోది. ఇది కూడా థియరిటికల్ పార్ట్ అండి, యూ హ్యావ్ టు గో అకార్డింగ్లీ. డిఫైన్ మ్యాగ్నటైజేషన్ ఆఫ్ శాంపిల్. Define magnetization magnetization of a sample. This is the first point. This is nothing but simply I and D, intensity of magnetization. And I told you intensity of magnetism is nothing but ratio of magnetic moment per unit volume, which is given by ampere into meter square by meter cube. So units ampere per meter. So magnetization of a sample is nothing but intensity of magnetization. It is the ratio of magnetic moment to that of its volume, ampere meter square by meter cube, that is ampere per meter. And it depends upon, this is an internal one, it depends upon H. I depends on H. This is external and this is internal. Okay, and of course I is proportional to H. I is proportional to H. If H increases, I increases. If H decreases, I also decreases. Therefore, I is equal to zeta times H, or I by H is equal to zeta. This is called as magnetic susceptibility. Okay, na? I by H is equal to zeta. Very, very important. And next, magnetic induction, susceptibility, and how magnetic induction is related to magnetic intensity. Okay, na? So when the influence vastayandi. So because this is another equation, I can put it 2. This one I can put as 1. Now just now I told you B is proportional to H plus I. In solenoid I told you. And this depends upon this one. This is 1. This is external. This is external magnetizing field. And this is internal I. I is internal magnetizing field. Are you following the point here? So that is why if more H value, I is also increased in solenoid. So I depends upon H. So when you use this proportionality, B is equal to mu naught times H plus I, leda B is equal to mu naught into H plus, already I means what? Zeta times H. Therefore, magnetic field is given by mu naught into 1 plus zeta into H. So these are some mathematical formulas relating to this last point and define magnetization sample, magnetic induction kuda adigadandi, and susceptibility. So the definition of susceptibility, ippudu cheppanu kada enti, ratio of intensity of magnetization to that of magnetizing field. No units because both cancel. Induction definition kavalante B ki, see, we know already F is equal to MB in magnetism, or F by M is equal to B. So it is the ratio of force acting on a unit pole placed in a magnetic field. Because you know what is F? F is equal to M into B kada. So what is magnetic field induction? It is also a force, vector quantity. It is a force acting per unit north pole. What is M here? Pole strength. Okay na? 1 ampere meter. Pole strength unit enti 1 ampere meter. So it is a force acting on the 1 unit north pole placed in the magnetic field. It is a force acting on a unit north pole placed in a magnetic field. And it is a vector quantity, units Weber per meter square or Tesla or Newton per ampere meter from this one. Force ki Newton, pole strength ki ampere meter. That's all. Clear? So adandi manaki inke migilipe how magnetic induction is related to magnetic intensity. ఇదిగోండి ఫార్ములా లాస్ట్ వన్ డెఫినేషన్ చెప్పేసాను జీటాకి, అలాగే దీని డెఫినేషన్ అయిపోయింది, ఫార్ములాస్ కూడా అయిపోయి, అలాగే ఇంటెన్సిటీ ఆఫ్ మ్యాగ్నెటైజేషన్ కూడా అయిపోయింది. సో కంప్లీట్ 4 మార్క్స్ క్వశ్చన్ ఇస్ కంప్లీట్ విత్ ద 6th one అండి. సో దట్స్ ఆల్ అండి. దీస్ ఆర్ సమ్ షార్ట్ ఆన్సర్ క్వశ్చన్స్ ఫ్రమ్ magnetism matter in the 7th video. Again I'll be meeting in the long questions, 8 marks questions in the 8th video. Okay na? Right.